Alright, good morning. I need you guys to find the book assignment we started on last time. Should be in your binder as number 53. Also a good idea to number the handout, today's handout, as 54. So take a minute to get that numbered and that out, please, and then we'll talk about the plan for today. Alright, guys, that's going to be mine if you can't follow directions. And I would love an excuse to take that.
How much is in there? Not much right now. He was just taking it back from us. He forgot it, yeah.
Alright, so last class we spent, I don't know, roughly half the time talking about the notes on section 5.3, solving equations, and roughly about half the class starting on the book assignment. So I know you are not very far through there, and that is going to be our main objective of class today, giving you some time to finish up the bookwork, get your questions answered, and to get as much done from the practice quiz as you can. So, one of the things I'd ask you to do for homework is I did ask you to try an extra 2 or 3 questions from the book assignment, partly to force your brain to think about the process again, and partly so that you looked at a few more questions and you might know a few that I could help out with at the start of class here. So, from the book assignment, if you don't have any questions ready, that is fine, but if you do, there's no sense in waiting. So, is there any book questions that you know you have that you would like me to start off with? Yes, John?
5.
We already did question 5. You need to pay attention in class. I'm not redoing questions.
Okay.
Yes? 21. Okay, 21 says cosine to the third minus cosine to the first is supposed to be equal to 0. Now, I'm sure I mentioned this last time, and I'm going to mention it a couple more times today, but I'll try not to do it every single time. But I know sometimes the hardest part of these questions is just getting started. So remember that if you just pretend like your cosines are just regular x's, sometimes rewriting it like this gives you a good hint on what to do. So to me, this looks like this probably should factor with a GCF and a difference of 2 squares. So this should probably do the same thing. It definitely has a GCF. The GCF is cosine x. Okay, and anytime you factor, really you want to factor completely. So it had a GCF and a difference of 2 squares. Again, basically the same idea as that to the right. And then in algebra, if you set each one of these equal to 0, you end up with your 3 solutions. But for us, the end of our question is going to be a little bit different. You got to set each factor equal to 0. And solve. And instead of those being your answers, these are where your answers come from. So cosine is 0. In a couple places. Cosine is -1 in one place, and cosine is +1 in one place. So looks like there's 4 places that could be a solution, and then you just have to pay attention to the directions. Your answer should look different if it says find the solutions between 0 and 2 pi, like questions 29 through 28, versus solve, like questions 11 through 22. And even though you're not looking at the practice quiz yet, the practice quiz is set up the same way because we do the same thing on the real quiz. You need to be paying attention to the directions based on how your answers look. So the long version of this would be to say 0 is a solution plus all of his coterminal answers, but also pi over 2 plus anything coterminal, pi and anything coterminal, and also 3 pi over 2 plus anything coterminal. I mentioned in the notes that on the quiz I would still give you full points because this is technically correct, but the back of the book's not going to make it look like that. You can make all 4 of those statements into a single statement by simply naming the first angle and then figuring out how much you have to add, assuming the rest of these are equidistant. Add pi over 2, add pi over 2, add pi over 2, add pi over 2, and then you start getting coterminal angles. And of course, adding 0 doesn't do anything. So this is completely optional, but this one statement is saying the same thing as those 4 statements. This is repeating 4 times as often as those. But you can only do that if the things are equally spaced out like this. Yeah.
Which question was that?
This is 21. Is it about this?
No, this is a different question.
Okay, I'm not.
Different number.
Okay, I'm not quite finished though.
Okay.
Okay, was that enough for 21? Okay. Okay, Jonathan, what's yours?
17.
17. So 4 times the cosine of what squared minus 1 gives you 0. So again, I'm not going to go through the whole thing this time, but if you're struggling getting started, change the cosine x's to regular x's, and however you would work this should be the first half of how you work this.
No, I'm just confused on how the answers work out because I can get my x.
Okay, so you added the 1 and divided the 4.
Mm-hmm.
You took the square root of both sides,
Yes, I did.
and you did not forget plus or minus.
Yes, I did. Definitely.
When you take the square root of both sides, you need plus or minus. So that could be the problem. But it could also be you have to know how to take the square root of a fraction in this section. And if something simplifies like those, then you should. And then anywhere cosine is positive or negative 1/2 should be a solution. So your answer could be all 4 of those plus 2 pi n, or you could do these two with one statement. That would be pi over 3 plus pi n.
So you choose any 2 points.
Well, it has to be 2 points that are equidistant. To get from this point to this point,
It's 2
I would add pi halfway around. And then if I added pi again, it starts getting the coterminal angles. It starts landing on this. And then for my purple dots, you could name the first one 2 pi over 3. And then if you add pi, you get this one. If you add pi again, you start getting coterminal. So
And for the quiz, we're fine just putting down the points.
no, you can't just put down the points. You can say, you don't have to condense into 2 statements. You could say pi over 3 plus 2 pi n. You could say 2 pi over 3 plus 2 pi n. You could say 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. It's just that these are equivalent. This and this are saying the same thing. But your answer has to match the directions. When the directions say solve, and it doesn't just say between 0 and 2 pi, you're going to need this in your answer.
Okay.
When you get to question 29, it's no longer going to be in the answer. That shouldn't be an issue, because if you guys are checking your answers and you see, wait, my answer doesn't look like that, you should get it corrected in the book assignment. But that can hurt quite a bit if you don't fix it before the quiz. Jack?
So it's not really about like a certain question, but
Okay.
so like let's take the red answer there.
Okay.
Let's say it was a different question. Does it say x equals pi over 3 plus 1/4 pi n, or does it stay pi n for all? Like, let's say like the distance was smaller for each equidistant dot.
Okay, let's say one of the questions, I don't know if this one y'all asked last time or not. What if the answers were here? You could say pi over 4 is where you could find the first one. And then how much do you turn if you want to go 1/4?
Or pi over 2.
Pi over 2. And if you add pi over 2 again, do you get here? If you add pi over 2 again, do you land here? If you add pi over 2 again, do you start repeating? So plus multiples of pi over 2. You could do that. Or you could do 4 statements. Pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n. You can do that too. It's just that if you can do it this way, it's the lazy way. It's less work to do it that way. So,
Thank you.
yes.
I did 17 a different way than you did. I
Okay.
got the same answer.
I'll have to look at it to make sure it wasn't just lucky. I'll come look at it in a minute. Did you have a question? Do you have one? No? That. Okay. Any other questions that y'all have ready to go? Okay. Then let me give you 10 to 15 minutes here to try to get another 2 or 3 questions behind you, and then I will bug you for questions again.
I divided it.
Oh, okay, you factored there, so these are equivalent. Yep, that's fine.
Yep. I should have recognized that as a difference of 2 squares, but I guess in that case they're probably about the same amount of work, so whatever it was. Okay, so again, I'm just getting out of the way for a few minutes to give you time to get a few more done, because you did not have to come with this finished, so you don't know what your other questions are until you start trying some more. Of course, those of you that chose to work ahead further than you had to, you are welcome and encouraged to move on to the practice quiz when you're done with the book assignment. And both of those are in Google Classroom, so you're welcome to scan the book assignment when you're done with it. I will see you guys again tomorrow because this is a B week, it's not an A week. Next week will be an A week. And then the week after that is finals, so that's different anyway. But you do not have to come to class with the worksheet finished tomorrow, but you should definitely have some of it completed. Tomorrow will be our 3rd class in this section and our last class to practice and get help and all of that kind of stuff. So tomorrow is not your 5.3 quiz. Next Tuesday will be your 5.3 quiz. But still got the book work to finish and the practice quiz to finish. And if you haven't looked at your semester test review in a while, a few of these question types are on the semester test review because a question or two like this will be on your semester test as well.
Just trust me. Trust me.
And the book, it says that's you over there. It would just be like
Well, yeah, but if you read the directions carefully, I think they kind of implied that they were gonna work, and they just wanted you to like follow through and see that they actually. It wasn't really like yes or no,
Yes or
it was just
no.
like, show yourself that these are real solutions.
Okay, so on my answer, should I just,
You know how cheap it is.
just my working okay, or should I put a check mark?
No, it's not. Just see that you plugged it in, you get a true statement, so you would know those are real solutions.
Thank you.
I'm gonna use that for 1 second.
Okay, just a few more minutes, and then I will bug you for another round of questions. I saw you on Facebook over the break. You were something with the animal shelter.
Oh, yep.
Yep.
That's my Girl Scout troop. If sine x equals cosine x, would
Mhm.
it be the square root of 2 over 2?
Anywhere where sine and cosine are equal.
So square root of 2, square root of 2, pi
Well.
over 4.
Okay, pi over 4 is one place, yes. Not 3 pi over 4, because one's positive and one's
that
negative.
one,
Mhm.
yeah,
Yep.
okay.
Pi over 4 and 5 pi over 4. All right, it's been about 11 minutes or so, let's check back in, and if you have found any more questions, let me know. 25, sure. Okay, so whatever you're working on, make sure that 25 is not one that you might need help with. Okay, so glancing at 25, I immediately noticed that this is like a quadratic because the biggest exponent is a 2. So I would either rewrite this with x's out to the side and think about how that factors, or carefully try to factor it this way as well. It's like it should factor like that. Remember, you can always check your factoring with FOIL. And if I set this factor equal to 0 and solve, it looks like some solutions come when cosine's a half, Set this factor equal to 0 and solve. Other solutions occur when cosine is -1. So cosine is -1 one time, and +1/2 two times. The directions just say solve, so we can say 3 statements, which would be pi/3 plus everything coterminal, pi and everything coterminal, or 5pi/3 plus everything coterminal. Or all 3 of these are equally spaced as well. These are equidistant. To get from here to here, I could add 2pi/3. From here to here, add 2pi/3, and from here to here, 2pi/3. So if you want to do it in one statement, list the first one, and then say add multiples of 2pi/3. The back of the book is probably going to do it that way, but this is fine too. Okay, that cleared up what you needed. Okay, was anybody else going to ask about 25? Have something more detailed there? Okay, other questions that you have found?
Would you do 27 the same way, or
27?
like those trinomials?
Yes, I would subtract the 2 over and then basically start it off the same way. Start it with factoring. The difference on 27 is at some point, probably like right here, how I set this factor equal to 0 and solved. I didn't really do anything else because it was already a cosine and I memorized cosine values. On 27 it's going to be secant. So you probably want to take the reciprocal of both sides to make it cosine equals, and then it's going to be familiar. Yeah.
Can you do 33?
33? Sure. Okay. If you did not need help with that one, that is fine, but you might want to glance at 33 for a second. Of course, if you are wrapped up in what you're doing, you can keep on going. You don't have to stop what you're doing to go to 33. But if you end up needing help with it later, you might need to watch the class recording. Okay, I really like question 33 and also 31. To me, they both kind of have the same first step. And this first step is important because without considering this, you just don't even know how to get started on this. And just for full disclosure, I'm not in charge of putting together this year's quiz, but I can tell you the last couple years, this has been a trick on at least one, if not multiple, quiz questions. The problem is, this is sine stuff and this is cosine stuff, so it's almost like 2 different variables. If you tried to write it like, I don't know, x's and y's, you can't solve one equation with 2 unknowns. But in trig, since everything's related, at some point the thing that has to cross your mind is that there is a Pythagorean identity that says you can take sine squared of any angle plus cosine squared of the same angle, and it has to equal 1. So we could either rearrange this and solve it for cosine squared and plug that in here, or we could rearrange this and solve it for sine squared and plug it in here. Both of those should be fine. It's just whatever you think looks like it's going to be easier. But if I solve this for sine squared, it looks like sine squared is equivalent to 1 minus cosine squared. Again, I'm not giving you any unfair information here, but I would be very surprised if you don't have a question or 2 on your quiz that starts off the same way. Now that it is all cosine stuff, now I can work it like previous questions. I can maybe add this over, just do normal solving stuff, divide both sides by 4, take the square root of both sides, don't forget plus or minus. In fact, I will highlight it. Have to remember how to take the square root of a fraction. Some of those should simplify. And so in the end, it looks like our solutions should come when cosine is plus or minus 1/2. So here, 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 and here. Here's where cosine's positive 1/2. Here's where cosine's negative 1/2. And the directions want the solutions from 0 to 2 pi. So it would be incorrect for my answers to have the plus 2 pi in stuff. I just need to list these 4 out. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Those would be your 4 solutions. Now, I have not mentioned this today, but I did try to emphasize it last time. I know in the bookwork, you guys have lots of ways to check your answers. You can check the odd ones in the back of the book. You can pull up the class videos on my website and see what the answers are as well. But just remember, so I know you're not going to do this on your book assignment much, but remember the first 2 questions in this book assignment were reminding you that you can check your answers. So on a quiz, it would be very lazy, if you had extra time, to not plug in pi over 3 to the original problem. The sine at pi over 3 squared looks like that. 3 times the cosine at pi over 3 squared looks like that. This ends up being 3/4. This ends up being 3 times 1/4. 3/4 is the same thing as 3 times 1/4. It does not take that long to plug it in and make sure that it solves the original problem. Pi over 3 is the solution. And of course, if you had more time and you didn't have to turn your quiz in yet, you could physically plug in 2 pi over 3, make sure it works, physically plug in 4 pi over 3, make sure it works, physically plug in 5 pi over 3, make sure it works. And then if something went wrong, at least you have a chance to fix it before it goes in the grade book. So again, I won't emphasize that too much, but you really should check your answers all the time on a quiz. Okay, any follow-up to number 33? Okay, let's aim for 1 or 2 more for now. 35? And I had said I'm not going to beat you over the head about checking your answers every single time, but this is a good one to follow up on that. So when I look at this, cosecant and sine, 2 different things, so it's almost like 2 different variables, like an x and a y. I don't see any basic algebra to be undone. I can't just undo add or subtract, multiply or divide. Nothing needs to be factored. I can't take the square root of both sides. There's very limited stuff that you can start off with. But you could say, well, this is the same thing as 1 over sine. So you could try to write it like that and see if that helps. I prefer not to solve an equation that has a fraction. So I would go through and multiply everything by a sine. 0 times sine is still 0. Now this looks much more like previous questions. I could subtract this over, divide by 2. How do I get rid of a square? Don't forget plus or minus. And how do I take the square root of -1? Okay, so imaginary solutions. And imaginary numbers certainly do exist. If your algebra teacher did not make that clear, I don't like that they're called imaginary because they certainly do a lot of stuff for us. But it is implied when we're talking about these, we're talking about real numbers. 0 to 2 pi are real numbers. There's no i's, there's no imaginary in those. So this doesn't happen for any real numbers, so no solution. There's nothing that's going to make that true.
Wait, why is that? Is it because you came out with -1/2? On the
Yeah, because this is negative. So sure, I could split this up, and the square root of -1 is I. It's just that I doesn't exist from 0 to 2 pi. We're only interested in real numbers. When I say real numbers, I don't mean numbers that really exist. I mean in mathematics what we call real numbers. So this had no real solutions. In a college course, they would expect you to make that distinguish. The other way, and again, I don't like to go too much on this because I know ours is no calculator, but this came up in my classes yesterday, and you can see I graphed each of these. I graphed 2 sine, and then I subtracted the cosecant over. Your very last book question is going to ask you to practice with your calculator like this. And then I graphed from 0 to 2 pi, and this kind of gives you a visual. The left side of that equation in blue versus the right side of that equation in red, there's no solutions. They're never at the same place at the same time. So sometimes seeing that visual helps you make that connection. Okay, let me give you another 10 or 15 minutes, try to get another set of questions completed, and just keep going till we are out of time. You can, it's just that you would also have to divide this by 2 if you're going to do that, which kind of creates a different issue. If you're going to divide something by 2, it's everything by 2.
I mean, like I said, there's some really.
See if I can help out a little bit more. Down to about 35 minutes of class. Actually, a little bit more than that, but still a bunch of time. But which ones are you struggling with? Check.
19.
We're 19. So sine of what times the sine plus 1 to equal 0. Now to me this one might look a little different to you because it's kind of like they've done the first step for you. Usually the question is going to start off like this, and you're going to have to see that you could take out a GCF of sine. So they've already done the factoring for you. So if this times this equals 0, if I can make this be equal to 0, then I don't care what this is, because 0 times anything gives me 0. Or if I can make this equal 0, then I don't care what that is. 0 times anything is 0. So it looks like your solutions should come anywhere where sine is 0. It's where the y value is 0 on the unit circle, and anywhere where sine is -1. So the long form of the answer would be to say 0 plus 2 pi n, pi plus 2 pi n, and 3 pi over 2 plus 2 pi n. And the short form, you could condense these two red ones because they're both spaced out by pi. You could say pi n, and then this one is not equally spaced with the rest, so he would need his own statement. Like that.
I was just overthinking that one.
Yeah. They're trying to help you by doing the factoring for you there. So
Thank you.
usually you'll need to factor it though. Okay, what else? Sure.
You do 31.
31. Okay, so 31 is certainly going to start off like one of those other questions you guys had asked earlier. I know that with about 5 seconds of thought here, because sine stuff and cosine stuff is like two different variables. So at some point you've got to think about, well, sine squared plus cosine squared is 1. So that means sine squared is the same thing as 1 minus cosine squared. So right here, instead of saying sine squared, you can put a 1 minus cosine squared. You okay with that stuff? Okay. Then distribute your 2. So we at least don't have parentheses anymore. Now when I look at what's left over, I feel like I've made some progress because the only thing in my equation is cosine stuff, not cosine and sine stuff. But also I noticed that this is basically a quadratic, so I'm going to move everything to the right, set equal to 0, and then subtract 2 from both sides, that goes to 0. And then finally, I can finish with GCF. They both have a cosine in common. So it looks like our answer should come when cosine 0 and when 2 times cosine plus 1 equals 0. So set each one of those equal to 0 and solve. And our solutions come anywhere where cosine is 0 or -1/2. And actually the directions make this a little bit easier here. The directions only want 0 to 2 pi. So just list them out. Pi over 2, 2 pi over 3, 4 pi over 3, and 3 pi over 2. Those are the 4 spots. And of course, if you had time, you can manually plug those into the original equation and make sure that they work. Okay, did you get what you needed there? But if, and I don't know if it was, but if you didn't know to switch this to this, you need to emphasize that and mark it up in a way that you'll look at it again before the quiz. Yeah.
Have you done numbers
I have not. Sure. Okay, 37 cosecant of what plus cotangent of what is 1. So again, two different trig functions, like two different variables. There's no regular algebra to be done. There's no factoring, no undoing add, subtract, multiply, or divide. So the only thing I can think of to even start this off is to consider changing this into 1 over sine, and consider changing this into cosine over sine. And I could add these fractions together. They already have a common denominator, so it's pretty easy to add them together. Now, right here, I'm going to have to put a star. I'm going to come back to this at the end of the question. But we could multiply both sides by sine, so now there's not a fraction. And now, to me, this looks like one of our questions in our notes. If we're adding one to one of these and seeing if it's the other one, you probably don't want to do this in an algebraic way. There's only 4 spots on the unit circle that are separated by 1. At 0, sine and cosine are 1 apart. At pi over 2, sine and cosine are 1 apart. At pi, and at 3 pi over 2. They're both 1 apart. So I would ask myself, if I add 1 to cosine, which is the x value, does it equal sine, the y value? If it does, it might be a solution. So if I add 1 to cosine, I get 2, does not equal sine. If I add 1 to cosine, it does equal sine. Looks like pi over 2 might work. If I add 1 to cosine, I get 0, which equals to sine, so that appears to work. And then right here, if I add 1 to cosine, I get 1. That doesn't equal -1, so that doesn't work. Okay, are you okay with that part? Okay, but these two are not the correct answers. And this is, I know this part can be kind of frustrating, but it goes back to, you should always want to check your answers to help eliminate any careless mistakes, arithmetic, whatever. But you guys also have to understand that sometimes in algebra, there are certain algebraic steps that create extraneous solutions. That means like our thought process is fine, what we're doing is fine, this solves this, which is equivalent to this, which is equivalent to this, which is equivalent to this. But sometimes one or both of these don't solve the original problem. And that's why I put a star here. When I'm just looking at this, there's no restrictions on what I can plug in. Cosine's always defined, sine's always defined. There's no values that make sine or cosine undefined. You think about their graphs, they exist everywhere. But this is just a representation of this. And if we look back here, we should notice sine cannot equal 0 because we can't divide by 0. So really, to be fully correct on this question, we need to plug this in to the original problem, and 1 over sine of pi over 2 would be 1, plus cosine of pi over 2 over sine of pi over 2 would be 0 over 1. So I get 1 plus 0 equals 1. That works. But when you try to plug in pi, pi makes this work. It's not going to make that work. Because if you plug in pi here, you get 1 divided by 0, which is undefined. If you plug in pi in these, you're going to get something over 0. You can't divide by 0. This should not be one of your final answers. This is what we call extraneous in mathematics. Extraneous means you didn't do anything wrong, your algebra's fine, your arithmetic's fine. It's just that some step of your algebra created a fake solution. So the only way to know for sure is to check it by plugging it in. Which again, you should want to do on every question because it helps you catch mistakes, and sometimes it's necessary. So something like this, multiplying both sides by a variable can create some fake solutions because sine can't be 0, and then when I'm looking at this, I don't know that that's an issue anymore. Another big one is if you, I don't know, if you chose to square both sides, when you square both sides of an equation, that typically creates extraneous solutions. So,
Is that a possibility to solve that way by squaring both sides?
yeah, you could. You can. It's just that, again, this often usually creates extraneous solutions too. And I didn't do this in the notes because I said to me, since there's only 4 places that are sine and cosine are 1 apart, it's just easier to check those 4. But yes, algebraically, you can square both sides, and that keeps it balanced. It's just that you would have to make sure that you actually FOIL this and not just square the parts. Like some of the questions you guys have asked, you need all sines or cosines, so you would need to make this replacement, and then you still have a quadratic. You still have to solve your quadratic with factoring, and then in the end, some of your answers may be extraneous, so you still have to check them. So it just, I don't know. It works in theory, but maybe not the most successful strategy. Yeah. I will. Okay, so 49 is a calculator question, and our quiz will be no calculator, so you don't have to, I mean, you have to have it done for the homework points, but this is not one that you need to stress about. We still like to keep it in here because, again, most of you guys should choose to want to go on to calculus next year. And on the AP calculus exam, half the points come from calculator stuff and half the questions come from no calculator stuff. It's not that the calculator just does things for you, but they do expect that you can solve something like this with your calculator. So I did the parts that I could do by hand, and at first you might be tempted to say there's no solution to this, but there is. Sine exists everywhere from -1 to 1, and -2/5 is between those. So this exists, it's just not a spot that I memorize. If you think about the unit circle, we really only memorize 3 different angles per quadrant. There's 360 different angles in here. We don't begin to memorize the whole thing. We just memorize the most important ones. So I know it happens somewhere, but I don't know where it happens. So in a calculator, and again, in calculus they expect you to know how to do this. This is not something we have time to sidebar and do for a full day. But you could graph one side of your equation like sine. You could graph the other side of your equation like -2/5. The directions say give answers between 0 and 2 pi, which implies your calculator should be in radian mode. And when I graph this, I really only care to look from 0 to 2 pi. So narrowing down my search a little bit makes it a little easier to see. But this blue line represents sine, and the red line represents -2/5. So anywhere they're at the same place at the same time will be a solution. So with the calculator, I can see that there's 2 answers to this. And simply using trace and getting the cursor close to those is not good enough. You need to be able to get it within 3 decimals for calculus. So if you do second trace, I'm guessing you probably use this one a lot in Algebra 2, calculate 0. Y'all did that in Algebra 2? Okay. Well, you need to make sure you ask about it second semester then. But for mine, I'm interested in intersect. So have the cursor near where there's an intersect, hit enter to identify the first curve, hit enter to identify the second curve, and hit enter to skip guess. Then your calculator will bounce that point back and forth until there's an intersection. They both equal -2/5 at about 3.553. 3.553. But also over here, so you would need to move the cursor closer to this one so it knows which one you're talking about, and then go through the same steps again. Second trace, calculate intersect, enter to identify first curve, enter to identify second curve, enter to skip guess, and then it will jump to that point for you. They are both -2/5 when x is 5.72. 5.872. And of course, calculator skills like that, knowing what your calculator can do and being able to do it quickly should also help you guys quite a bit with the ACT. There's a lot of ACT type, well, I haven't taken an ACT in a long time, but typically there's a lot of ACT questions where if you're very good with your calculator, you know what it can do, there are times you can work certain questions faster, even if you know how to do them by hand. So, okay, you guys got more questions ready? Okay, let me set just one more timer here. We've got about 21 minutes of class, so let's do one more 10-minute timer. Give you one more chance to speak up and try to answer all those for you. I guess if you still have more, you'll have to lean on the website videos. But that'll give me time to answer the questions you found and make sure you know what the plan is for tomorrow so that you are prepared and ready.
Can I go to the library or notebook?
Not right now.
Okay.
Alright, it's been 10 minutes and we've got about 11 minutes of class time left, so give you another chance to get some more help. Anything that you've not asked from the book assignment that I can help on? Yep. 29. 29. says sine minus 2 is supposed to equal cosine minus 2. Well, the first thing you should do is you should want to add 2 to this to make it go away, and then you have to add 2 over here to keep it balanced, which is good because it just simplifies the problem for us. So adding 2 to each side, we just need to figure out when is sine and cosine the same. So algebraically, you could square both sides, change one of these into cosines or the other one into sines, but when you square both sides, you might create extraneous solutions. And this is an example of one where I think it just makes sense for you to try to think about the answers instead of doing it algebraically. If you go around the unit circle, there's only 2 times where sine and cosine are equal to each other. At pi over 4, they're both the same thing, square root of 2 over 2. And at 5 pi over 4, sine and cosine are both negative square root of 2 over 2. So your answers would be pi over 4 and 5 pi over 4. So if you want a challenge, go ahead and square both sides and try it out. Just make sure that you check for extraneous solutions if you go that route. Okay, is that enough for 29? Okay, you got another one? What you got?
45.
45. Okay, so 3 times the tangent of what divided by 2 minus the square root of 3 gives us 0. Okay, so the basic stuff that we can start off with at least is we can undo the subtract with add and undo the times 3 with divide 3. But what makes this question and other questions in 39 through 46 a little bit different is these are considered multi-angle equations. This isn't just tangent x, it's tangent of 1/2 times x. So the way that I think works the best is pretend like it says x for a second and go around the unit circle and identify everywhere where tangent is square root of 3 over 3. Of course, this is a lot quicker if you memorize those 3 tangent values, so you don't have to do a bunch of guess and check. You get these 2 spots and you start to write out your answer. X could be pi over 6 plus anything coterminal, or 7 pi over 6 plus everything coterminal. And then the only additional step you need to do is to catch that I didn't really solve for x. I wrote it as x out of convenience. I have solved for 1/2 x. X over 2 is the same thing as 1/2 times x. So I don't really have the answers yet, but I can take this from 1/2 x equals to just x equals by multiplying by 2. And if I multiply this by 2, everything has to be multiplied by 2. This and this. Same thing with this guy. Multiply everything by 2 so that it goes from 1/2 x equals to just x equals. And then the direction said solve, so it expects my answers to be written in this format. So it's already there. So it's really just one extra step. You just have to remember to multiply your answer by 2 since it was a 1/2 there. When it's a 3, you need to divide everything by 3. When it's a 2, you need to divide everything by 2. And I don't know if I can find it, but I guess while you guys are looking for another question or so. See if I can find it. Yeah, so I told you that this had randomly came up in calculus a couple weeks ago. So you can see, and this might be one of the very few times that it came up the whole year. You wouldn't understand this first step, how to go from this to this, But everything after that is what you guys are doing. Multiplied the 2's. Well, you don't know why I put it equal to 0, I guess, but then I had to solve this. Multiplied both sides by -4. This was a double angle. I pretended like it said x for a moment, wrote out my answers, divided everything by 2, divided everything by 2. So 95% of what was challenging about that question was the exact same thing that you guys are doing in pre-calculus. So, of course, it makes it a little bit easier if you understand it and you're not trying to relearn that while you're also trying to learn a bunch of calculus at the same time. Okay, one more, or was there any more? Okay, then just a quick little reminder here. Should have had time, class time, to finish up those bookwork, get your questions answered, but if you did not, you need to catch back up to everybody else with homework. Also, please start the practice quiz. You don't have to have it 100% completed, but tomorrow is our last day of questions and practice. So you need to have time to finish the practice worksheet, the practice quiz, and make sure that you have time set aside that if you need some help on them, you have time to ask. So we'll finish up this unit, this section tomorrow, quiz it on Tuesday of next week, and then we'll have 2 classes of nothing but semester exam review. I'm setting in for that. Don't forget, if you want to apply for exemptions in this class, you are welcome to. You have to meet all the class requirements and you have to finish the semester exam review. But one of the requirements to exempt any class, this class or others, is you have to apply on time. And that is opened up now.
Is it on Google Classroom or where can we find the application?
It should be in your student announcements in your school email.
And is it 4 or less unexcused absences? Or 4, just straight up 4?
There's a lot of stuff. That class absences and tardies and advisory absences. But as of right now, it's for more than 4 unexcused.
So what if we have 4?
Excused or unexcused?
Unexcused.
Well, this is more than 4, so my understanding would be that they would
Waive
approve
it. Okay.
Is there a way to see all these, like how many unexcused absences you have for classes at Hack or?
And grade view
Grade way.
somewhere.
I'd do grade way and do it.
Jeez.
What do you listen to? Like music class?
Or
You don't listen
What?
to music?
No.
Really?
No, I don't understand. The question's random.
I'm just